In this video, I'd like to look at using R to read some data from an Excel file and then manipulate it. So here is the Excel file. So it has 3 runs of, this is a cart running down an incline. And so there's some row here that says just what was on the cart. One block on the cart, 2 blocks, 3. That doesn't matter. Here are what is being the labels of the columns, and then there are some blank columns, and then another thing that's going to come up is that this data was run and the cart went down the incline, and then at some stage it hit like the bottom and bounced, and so there's some bad data. So we're going to want to play with, columns, getting rid of columns we don't want, getting rid of some rows we don't want. So, you know, some Excel challenges. Okay, so here we go. So let me get rid of this Excel. Okay, so this, I'm using a library that reads Excel, readxl, and the first time I used it, it gave me a little message up here. You don't have that installed. Do you want to install it? I said, yes. I wait a couple of minutes, it installs. Okay. So the first time you use it, you will need to do the same. Okay. Now so that's what 2 is announcing, and then 3 we're reading in the Excel. So I had that Excel somewhere on my Windows machine, somewhere on my C drive. I had to found the properties of the file. It was giving me backslashes. I had to turn my backslashes into forward slashes. Okay, and there are different parameters for readxl. I'm going to keep it fairly simple. It wants to assume that the first row are the headers, and I had sort of 2 rows. So I'm just telling it to skip 1 row, and then I'll deal with everything else when it comes in. Okay, so, but there are other options where you could say range, and I could tell it I wanted stuff from sheet 1 from, A2 down to, H, 100 or something. So there were other possibilities here. But this skip was sort of simple, and I'm sort of used to, in a number of programs, saying whether I have headers or whether to jump over the headers or what have you. So that was a pretty simple one. If you can't use it in conjunction with range, so either you're going to do the simple skip, which is what I'm choosing to do, or you're going to use range, but not, it's going to jump over, ignore your skip if you use range, because range is, so if you want to skip things, then you have to have like the sophisticated range to sort of say, start with A2 or start with A3 or whatever A you want to start with. Okay, so that, let's run those lines 2 and 4 there. And we brought in the data. And there were 81 observations of 9 variables. Okay. So we saw that there were there were time and positions for 3 runs with blank rows in between. And it's picked up sort of 1 extra blank column. So altogether it's saying there are 9 variables, 81 observations. And so we want to get rid of some of that, pare it down. Okay. And if I wanted to bring in 1 run at a time, then I could use that range to sort of say, like, all I really want is run 1 or something like that from this data. Okay. Now I used type of and printed it out and found out that what came in from read_xl was a list. I'm used to working with data frames. So the next thing I do here, is cast it as a data frame. So now I'm going to have, what I'm used to working with in plotting and so on is a data frame. So I'm going to cast it as a data frame. So now it's a data frame. I prefer that structure. Okay. Now, when I did that, I had a previous video where I read in a JSON using a different library to read JSON files, and that created a list. And when I tried to do a simple cast to a data frame, it sort of just wreaked havoc. So, but here it seemed to work. The expectations of what come in from Excel or the type of list made was easier. Okay. All right. Then what I want to do is see what the names of these things are. So this should be the columns, that first row. So I'm just going to take this out, clean it out, and clean down here with Control L, and then run all of this again. Okay, so now here are my names. These were, I skipped the first row, and here were the head. So first one was time S, and then position, and then just that 3 was a blank column, 4 was another time, 5 was position, 6 was another blank. That's what we've got. And now I'm saying I'm going to rename them. So I have some, I'm going to rename them T1, X1, and blank 1, T2, X blank 2. So I'm just renaming them just to show them I can. And then I'm going to eliminate the blanks. So now I have the names are my names, T1, X1, blank 1. And now I'm going to next here eliminate those blank columns. So I'm taking my incline, there's a minus sign here. So I am sort of taking out, subtracting, if you will, and I'm subtracting out columns 3, 6, and 9. So this thing starts counting at 1. Okay, so it was the 3rd and the 6th and the 9th column were the blanks, and I don't want them. And so I'm going to take incline, get rid of those 3 columns, and call it incline again. So we should see this go from 9 variables to 6 variables. Now it's 6 variables. I got rid of my blanks. Okay. I'm going to use incline to plot the first run of data, which was X1 as a function of T1. And so I'm going to use the tilde notation and give my my Y variable so that my X on my plot is the times and my Y are my X's. Okay. Within the plot. So now here's a problem. I sent a cart down an incline. I expect it to accelerate. This is position versus time. So I expect it to be a quadratic polynomial of order 2. I expect there to be some acceleration. But as I said at some stage when I was talking about the Excel, it like hits the bottom of the incline and kind of bounces and does a weird thing here. So I don't want this data. Now I could go back to Excel and eliminate it there, but what I want to do is delete it here in R. So I'm just going to do it for run 1. Now it turns out that these data probably the cutoff point for all the data is probably the same, but I don't want to assume that. So I'm going to extract just the run 1 data from all of the incline data and then cut off the data. So here I'm using that incline minus C in a list of columns, 3, 4, 5, 6, but I'm not calling it incline again, I'm calling it run one. So I'm not rewriting, I'm not overwriting my original data set. I'm just extracting the run one data set from the whole set of incline data. So that is 21 there. And so now I have a run one data, which is just 81 observations of 2 variables, but I want to get rid of these observations at the end. They don't obey the same physics. It was freely rolling down the incline and then it bounced. And so things changed. So I want to eliminate that bad data. And I sort of looked roughly at my graph and said, oh, 5.5. I don't want, after the time was 5.5. And this was just a rough thing, just by looking at the graph. And so I'm going to use subset. I'm going to take a subset of run one. I'm only going to keep the data that's less than 5.5. And then I'm going to take that subset and rename it run one. So this should drop down from 81 observables to, I don't know, 50, 60 or something like that. Let's see. So it's 54 observations now. Okay. So now I want to plot this data. It's going to look an awful lot like the graph that is there, but it was not going to be this weird bouncy tail stuff. So I'm doing x tilde t. So my position was on my y-axis, time was on my x-axis. I'm giving it a title. I'm labeling the x-axis time, and the y-axis label, I'm labeling position. So I'm going to make a new graph of without the bad data. There we go. There's one little doodah point there at the end. Maybe I should have eliminated that, but let's keep it. And then the rest is just some standard fitting of this graph. I'm going to use a linear model. I'm going to fit the position data. I'm going to get it as a model of the time as a function of time, but also include time squared. So I'm going to fit it to a quadratic. And then I'm going to get a summary of that fit so I can see the coefficients. So here down here in the console are here's my results. This column here, this first column, the very first column is the names. And if I want the second column are the coefficients I want. And so I'm pulling them out. Run one underscore fit, that's what I call the fit. $sign coefficients, and then I have to match these names down here. So I called it A was the quadratic term, B was a linear term, C was the constant term. So you'll see when I run this, they'll appear over here in my environment variables. So now I have ABC. I want to plot that graph and add it to my data. So here's my function. When I use the curve method, it likes, I know that on my x-axis is time, but when we're using the method curve, it likes the variable to be called x. So it's ax squared plus bx plus c. I'm going from 0 up to t is 5.5. I'm adding it to the data. I don't want just a picture of the plot, but I want it with the data, and I'm going to make it a blue. Did I run that? I think I did not. So there, now you can see there's a blue line. It's going mostly through the data. It keeps a lot of digits. It doesn't show them here in the environment, but it keeps an awful lot of digits. And now I want to display the equation, and I don't want to have so many digits in my display. So I am rounding A and B and C all to have 3 places after the decimal place. And so I'm going to run that. And then I'm going to put together an equation of y equals a, the quadratic term, the square term, plus b, the linear term, and c, the constant. And I switch it back. This is just a display. So curve wanted it to be called X, but now I'm displaying it on the graph, and I can call it what I want. So this is just creating it, creating the thing to be displayed, but not displaying it. So it'll appear over here in my environment. There it is. And then finally, I'm going to add it to my graph with text. It's text, an X and a Y. So I'm going to put it at an X of 2 and about a Y of 2. And then what am I putting there? I'm putting my fit equation. And there's my fit equation sort of centered at the 0.22. All right, that's what I wanted to show you, mainly this Excel stuff, the Excel library, the simple data frame cast worked well. I've seen it not work well with when I had JSON, but it seemed to work well here with Excel. Rename the columns, eliminate some columns. Later on, select out some columns without eliminating all the data. Eliminate some of the rows based on a condition, and then carry on with the data, fit it to, in this case, a quadratic, and display it, and so on. All right, that's what I wanted to show you. Thank you much for your attention.